researchers at Eötvös Loránd University in Budapest, Hungary, have unveiled the world's first large-scale autonomous drone traffic solution. This groundbreaking achievement promises a future where drones navigate the skies with unmatched efficiency and safety. The team at ELTE has been at the forefront of drone technology since 2009. They first created an autonomous quadcopter flock in 2014. Now they've demonstrated dense autonomous traffic with 100 drones, surpassing their previous milestones. Flocking involves drones moving in perfect synchronization, like birds. Autonomous drone traffic, however, is more complex. Each drone has its own route and goal, leading to potential conflicts. The ELTE team tackled this by developing a smart, real-time updating route planner, combined with traditional flocking models. This new method helps drones avoid most traffic conflicts and manage any remaining issues by coordinating directly with nearby drones. Initial simulations showed continuous, high-speed random traffic, with up to 5,000 drones in both two-dimensional and layered three-dimensional settings, proving the model's potential for dense drone traffic. The model was programmed onto a fleet of 100 drones owned by Colmot Robotics Limited, a company founded by ELTE's Department of Biological Physics. The live demonstration marked a major milestone, showcasing the potential for automated drone operations in various industries. This autonomous traffic solution could revolutionize industries from agricultural spraying to cargo transport and defense operations. ELTE's research paves the way for smart cities and decentralized air traffic control, making once sci-fi ideas a reality.